Hey everybody, this is Larry. This is day 28 of the August Leetcode Daily Challenge. Hit the like button, hit the subscribe button, and let's get started. Join me on Discord and implement Rand10 using Rand7. Given Rand7, 1 to 7. Okay. Yeah, I mean, okay. What are these? Oh, they're just numbers? Hmm. So there are a couple of ways we can do it. The most naive way is just we do it twice, and if it's outside of you know, you have two numbers, and you can. I was gonna say you could add them, but then that doesn't give you a even distribution because then you have this binomial thing, right? So you could just multiply them and then if it's not from from 1 to 40 or whatever it is, then now can you multiply them? I mean, I guess the most naive way is just do it 10 times. And then sum it up. Is that right? My math is really terrible today. I think that should be rough. Yeah, I mean, I think for some reason I think I'm square root, but I think what I actually wanted to say was just do a base 7. Oh, sorry, I think of square, but yeah, this is one of those one-off farms, maybe even in the real farm, but it doesn't really come up that much. So my tools are a little bit rusty for it. So that's why I'm thinking about it again. But it is a good problem to think about. It does come up like I think I solved a similar problem in elementary algorithms back in college. So definitely, it's a fun brain teaser problem. And yeah, and I think I was thinking of squaring it to get the base 7. But what I actually want is just the base 7. And then now we have a base 7 number. We can just divide it by. In this case, it goes. The range is from 1 to 49. We just want to get it to 1 to 40 divided by 4, so that we get 1 to 10. And then we roll it, right? If it doesn't, and you could do another way as well. You could have this base 7 number, and then if it's not between 1 to 10, but then you would re-roll a lot of times, right? So yeah, and we'll do the math afterwards. Maybe we do these follow-up questions, but yeah, so that's what I'm going to do for now. So now we have, let's just say, a Rand 49. Which I guess, is it Rand 49? I guess it's Rand 49. It just depends on if it's 0 based or 1 based is what I was thinking of. So yeah, so this is just return Rand of 7 times 7 plus Rand of 7. Maybe plus 1. Wait, is 1 7? 1 to 7. Okay, so actually minus 1. Because yeah, and this is also minus 1, but then you want to plus 1 again, right? I'm just trying to think about the edge case of like, okay, so if this is 1 and this is 0, sorry, if this is 2, this is 1, then this would be 7, right? So okay. And then now we do while Rand 49 is less than or equal to. I'm just going to do this in. So this gives us a number from. Just to be clear, this gives us from 0 to 48. So yeah. So now while this is less than 40. Or this is greater than or equal to 40, we is the what's it called, Walrus operator in yet? I don't know. Let's try. If not, then we just do it. It's fine. something like that, right? Yeah, I guess it's just getting random numbers. Let's see if it gives us any issues. Okay, the walrus operator kind of works, but not really. Oh no, this is fine. For some reason I thought it was 7. Let's try again. I mean, randomness is always tough to kind of eyeball, but it looks okay in that it doesn't give you anything bigger than 10. It doesn't give you anything smaller than 1, right? So yeah, let's go submit this, and then we'll analyze this code laterwards. Cool. Yeah. Again, so this takes some practice, and I just woke up. That's my excuse. But you know, it took me a little bit to catch up on it, because I was saying some, because you know, and one thing is just with experience you can at least validate your dots very quickly, right? I said, oh, you could just add them, and then you know, and it adds up to 14, and you just take the 1 to 10. But then I was like, oh wait, no, that's just obviously binomial. Choose 2, so then that means that you have this like peak thing, right? But that was not going to be uniform. And then I said squaring, not squaring them, but multiplying them. But then obviously you're not going to get the right distribution, even though it goes from 0 to 49, or 0 to 48, or 1 to 49, I guess. So the domain is right, but it's a little bit off because it's not, you know, every number is going to be not equally represented. So then I just remembered, I was like, oh yeah, you just need a base 7 number. Yeah, and basically, so what is the expected number of cores, right? So so if you do something like, so you could also do something like this, and it would probably work, but it may be a lot slower. So if you have something like this, then, well, what's the chance of success, right? So the expected value of x is equal to, just expected value of x plus, in this case, it is, well, this is 1, but, I think I just messed up. It's, like I said, so it's 4/5, roughly speaking. I mean, I'm hand waving is actually, okay, fine, let's just be precise then, right? So it's like 39 out of 49. Chances, maybe I'm off by 1, but it's still roughly right? So this is the recurrence, and if you solve for it, then it's, you know, it's a lot more. I'll leave that as an exercise at home. There's a formula for it. But if you do something like, you know, and if you reduce this to 40, then you reduce this to 9 over 49 times e sub x plus 1, and you know, and this is clearly convergent, because you can show that this is clearly less than, this is clearly less than 1/2 e sub x plus 1, and this obviously is just, maybe not obviously, but if you have this formula of e of x is equal to 1/2 e of x is equal to 1/2 e of x plus 1, that's just like a classic conversion of you know, is 1 plus 1/2 plus 1/4 plus ... right? And that obviously is just, you know, linear slash, you know, well, not linear, sorry, it's just 2, right? So that's what the convergent series is. So that, and because this is less than, the function that we're doing is less than this, that means that we're only going to call this less than 2 times is the expected value. And you know, and each of these calls this twice, so you could say it's less than 4 as an expected value. Can you minimize the number of calls for it? You can probably do some funky math with different bases or something like that to play around with it, so that maybe the number of calls. But that's all I have for this one. I think I'm confident with it, so I'm okay. Let me know what you think. Let me know if you optimized it or did it a different way, because I assumed, or I think there are probably a couple of ways to do this. So let me know what you think. Let me know how you solve it. Hit the like button, hit the subscribe button, join my Discord, and I'll see y'all tomorrow. Bye bye.